Good day, Naija Pikin. Welcome to our channel. Do not forget to like and hit the subscribe button. Today, we'll be looking at an interesting topic under biochemistry called lipoprotein metabolism. Lipoprotein metabolism. So, the first thing we need to know is our food is rich in cholesterol, some cholesterol esters, and even some free cholesterol. And there's a way the body uses up this cholesterol and some triacylglyceride or triglyceride and find a way of dissipating it from one place to another, from the liver, using the liver and the intestine, pushing it into the bloodstream, and also distributing these particular fat molecules to other peripheral tissues. So there are two pathways when we're talking about the lipoprotein metabolism. You have the exogenous pathway and the endogenous pathway. In the exogenous pathway, this is the food substances that are rich in lipid molecules such as cholesterol, cholesterol esters, and even triacylglyceride. What we eat, the things we get from what we eat in our diet. And they are synthesized and sent to other peripheral tissues for their biochemical activities. While endogenous pathway is the pathway in which these particular lipids are synthesized in the body. So let's talk about the exogenous pathway. So let's say you've eaten, and I told you the food is rich in cholesterol esters, cholesterol, and some triacylglyceride, and even some free cholesterol. So when you eat, so I'm going to call these food substances that are rich in cholesterol and cholesterol esters and lipids called fat globule. So I have my fat globule here. Let me call this my fat globule. So I have some triglyceride, I have some cholesterol, I have some cholesterol esters. So the stomach has the ability of pushing this particular food globule close to the walls of the intestine, the mucosal lining of the intestine. When it does so, this triggers the submucosal nerve plexus to trigger a chemokine or a chemical receptor found on the mucosal wall of the intestine. This particular chemical receptor or chemoreceptor is called cholecystokinin. So let's take this. Sorry, excuse me. Let's take this as my CCK, which stands for cholecystokinin. So cholecystokinin now triggers the gallbladder. Triggers the gallbladder in the liver. So this is my gallbladder. Let's represent this as my gallbladder. There are smooth muscles surrounding the gallbladder. There are smooth muscles surrounding the gallbladder. So there is a duct that comes out from the gallbladder. That duct is called the cystic duct. So from the liver, there is a duct that also comes from the liver. And fuses with the cystic duct. It fuses with the cystic duct. This particular duct is called the common hepatic duct. So these together fuses. They fuse together and form what we call the common bile duct. They fuse together to form the common bile duct. This is very important. There's a reason why I'm giving you this illustrative diagram so that you understand what the function is what's the function of CCK, and how does it allow the gallbladder to contract and releases bile into the intestine that will help in the emulsification of this fat globule to fat droplets or emulsion droplets. So I told you the cystic duct combines with the common hepatic duct, fuses together to form the common bile duct. So close to it, forms the common bile duct that is close to where the pancreas that is close to the intestine, where you find the pancreas close to the intestine. So there is a duct that comes from the pancreas. So let's draw our pancreas. Let's draw the duct here. Excuse me. So CCK will be here. Let me call this CCK. CCK triggers the gallbladder. So there is a duct. Let's say the duct is coming from the pancreas close to the intestine. So it fuses with this and goes directly into the intestine, forming the hepatopancreatic ampulla. So this is the main pancreatic duct. This is called the main pancreatic duct. Which fuses with the common bile duct to form the hepatopancreatic ampulla or the hepatopancreatic duct. So after that, what do we need from the gallbladder? We want the cholecystokinin or the CCK, the chemoreceptor, to trigger the smooth muscles around the gallbladder to release bile, because there is something in bile that we need for the emulsification of the fat globule. So when it contracts the muscle around the gallbladder, the gallbladder has bile. And what are the constituents of bile? So the constituents of bile, we can have water, we can have some phospholipids, we can have bile salts. So this is what we should be focusing on, this bile salt, and even some electrolytes. So we are focusing on the bile salt, and the bile salt are of two types. So my bile salts are of two types. I have the oxycholine, and I have cholic acid. So these are the two types of bile salt, the oxycholine and cholic acid. So this is what I want to bring into the intestine. This is what I want to bring into, so that it can help me emulsify the fat globule, which was pushed by the muscle that stimulated the submucosal nerve plexus to stimulate CCK that triggers the gallbladder to contract. So now I have my bile salt here. So my bile salt is here. So let's say this fat globule is floating on water. Yeah, there is water here. Call this. So it cannot sink because water and oil can't mix. So we need something that will be able to allow this fat globule to go inside, to sink, so that it can be emulsified. So that is the function of the bile salt. So now my bile salt would surround, let's say the bile salt surrounds this fat globule. This is my bile salt surrounding the fat globule. So when it surrounds it, mind you, the bile salt has what we call the hydrophobic portion. The hydrophobic portion, or the lipophilic portion. Lipophilic in the sense that it is lipid loving. So the hydrophobic side of the bile salt is able to bind to lipids or fats, while the hydrophilic portion of the bile salt, or the lipophobic portion of the bile salt, is able to bind to water. So once it binds, it's able to sink inside. So what now happens? This bile salt helps in emulsification of the fat globule into fat droplets or emulsion droplets. So this is a bigger size, so it becomes something like this, smaller than the usual size. So I still have my triglyceride, my cholesterol, and even some cholesterol esters. And the bile salt is still surrounding it. Let's make the bile salt with black. Yes. So my bile salt will always be black. Good. So once we have this, Now again, the pancreas releases an enzyme that helps in the continuous breakdown of these fats or emulsion droplets into smaller sheathings, into smaller particles. There is an enzyme secreted by the pancreas called pancreatic lipase. Pancreatic lipase. So the pancreas releases an enzyme called pancreatic lipase through the hepatopancreatic ampulla. Pancreatic lipase, which helps. What is lipase? It means it's lipid. It breaks down lipid. It breaks down lipid into smaller units. So pancreatic lipase breaks down these particular emulsion droplets into smaller sheathings or smaller particles. So now let's say this is my happy pancreatic lipase ready to chew. Pancreatic lipase ready to chew this particular fat droplet or emulsion droplet into smaller sheathings so that it can be able to be sent into the enterocyte for other chemical activities. So it binds to something on the body of, it binds to this particular portion on the body of the emulsion droplet called co-lipase. This is called, so the pancreatic lipase binds to co-lipase and does the breakdown of this particular fat globule, emulsion droplet into smaller sheathings. So when it does so, it becomes smaller than this size. It becomes smaller than this size. So let me take this here. So it becomes smaller than this size. So we will have something smaller than this. So I still have my triglyceride, some cholesterol, and some cholesterol esters. And mind you, there are other fat soluble vitamins that would say, okay, I would love to hop on this train and see if I can also go into the bloodstream. What are those fat soluble vitamins? We have vitamin A, D, E, and K. Please, I would like to hop in so that I can be taken also into the enterocyte for other chemical activities. So it's more smaller than the fat globule we had from the initial. So what we now have now is called a micelle. So understand that the emulsion droplet is not what is taken into the enterocyte. It has to combine with pancreatic lipase, with the co-lipase, and break it down more into smaller sheathings to give you what we call a micelle. So the micelle is now taken into the enterocyte. We are zooming into the enterocyte, the intestinal cell or the cell of the intestine. We are zooming. So now it comes in. When it comes in, after this breakdown, once pancreatic lipase connects with co-lipase and breaks it down, the triglyceride that is broken down forms free fatty acid. After this breakdown, after this combines with this, so it makes the triglyceride is being broken down to free fatty acid and glycerol or monoacylglyceride, MAG. So this is what is taken into the enterocyte. Once it's in the enterocyte, there is a special organelle called the smooth endoplasmic reticulum. The smooth endoplasmic reticulum. Smooth endoplasmic reticulum, SER. The function of the smooth endoplasmic reticulum, after this glycerol and monoacylglyceride and free fatty acid is being taken in, you have it here. What it does, now let's say this is my monoacylglyceride and free fatty acid. So what the organelle does is trying to package, it packages the monoacylglyceride and the free fatty acid to form what? TAG. Again, to form triacylglyceride or triglyceride. Then there is another special organelle in the enterocyte called the rough endoplasmic reticulum. The rough endoplasmic reticulum. Let me get a better diagram so that it looks fancy and nice. The rough endoplasmic reticulum. Rough endoplasmic reticulum. The rough endoplasmic reticulum produces a special protein which will bind with the TAG to form a special molecule. What is that special protein? That special protein is called ApoB48. It produces ApoB48. So combining all this together, my phospholipid, I have my triacylglyceride, I have some cholesterol, still have cholesterol, and even some cholesterol esters. So, and what? B48. The protein that was produced from the rough endoplasmic reticulum, B48. This particular molecule is called chylomicron. Chylomicron. It's called chylomicron. So I'm going to represent it in black. Chylomicron. Isn't that beautiful? This is the first lipoprotein that we made. Chylomicron. So I'm going to just take you back a little so that I know we are on the same page. This is called chylomicron. So the stomach pushes the fat globule close to the mucosal of the intestine and triggers the submucosal nerve plexus to trigger a production of a chemokine or a chemoreceptor, which is called cholecystokinin, which triggers the smooth muscles around the gallbladder to release bile through the hepatic pancreatic ampulla into the intestine. I'm just so happy that I'm doing this, and I hope you take these keynotes because they are very, very important. So it goes through the hepatic pancreatic ampulla through the bile salt. Well, the bile salt passes through the hepatic pancreatic ampulla and helps in the emulsification of the fat globule to release emulsion droplets or fat droplets. The pancreas also releases pancreatic lipase, which connects with co-lipase to break down this particular fat droplet into smaller units called micelle that will be taken into the enterocyte. Once it breaks this down, TAG or triacylglyceride is being broken down to form free fatty acid and monoacylglyceride, which is taken into the enterocyte, packaged by the smooth endoplasmic reticulum to give you triacylglyceride, while the rough endoplasmic reticulum releases a special protein called B48, which are all packaged, encompassed by the phospholipid called chylomicron. So the molecule now that is formed from all this lipolytic pathway is called chylomicron. So we are now taking the chylomicron into the blood vessel. But what happens? It doesn't just go into the blood vessel. There is a lymphatic drainage that helps in draining in this lipoprotein into the blood vessel. When it drains it, it passes through a particular place on the lymphatic drainage or the lymphatic system called lacteal. So when it's going into the blood vessel, there is a lymphatic drainage called lacteal. I am very sorry, but you have to know all these things. You have to know them for you to understand and have an effective knowledge of lipoprotein metabolism. So the lacteal drains the chylomicron and passes it through the thoracic duct and dumps it inside the blood vessel. You know, if you know your anatomy very well, the subclavian vein connects with the jugular vein to form the bronchocephalic vein. On that junction, that is where the thoracic duct dumps this particular molecule called chylomicron. So now the chylomicron, this is the thoracic duct. This is my thoracic duct. So the chylomicron now, it's inside the blood vessels, it's inside the bloodstream. So this is my chylomicron. I have some high amount of triglyceride. I have some cholesterol and even some cholesterol esters. What is the protein that is associated with it? ApoB48. B48. B48. Once it's inside the bloodstream, there is a special molecule that says, hey, I need to dump some proteins to you so that you can continue your chemical activity. That particular molecule is called HDL, high density lipoprotein. HDL. HDL. High density lipoprotein. High density lipoprotein. It says, oh, chylomicron, please, I need to give you some protein so that you can continue this lipolytic pathway. I have 2 proteins that I'm able to give you because I'm a lover. I would give you. So it gives the chylomicron. So I'm going to represent chylomicron as CHY. It gives the chylomicron 2 special proteins. What is the first protein? The first protein is ApoE, while the second protein that it gives to the chylomicron is ApoC2. ApoE and ApoC2. So once it gives the chylomicron these 2 proteins, so what we will now have, the chylomicron is now this. We have protein ApoE and I have ApoC2. Good. This is beautiful. So the chylomicron comes into the bloodstream through the thoracic duct. The HDL has notice of it and gives it 2 particular proteins, ApoC2 and ApoE, and attaches itself to the chylomicron. So this is what the chylomicron looks like. So we are continuing the lipolytic pathway, or the lipoprotein metabolism, or metabolic pathway. So we now have C2. There is a receptor on the that surrounds the blood vessel, the capillary, which is able to take things to other peripheral tissues. This receptor is called lipoprotein lipase. So this is the receptor. This receptor is called lipoprotein lipase. So C2 binds with the lipoprotein lipase and breaks down triglyceride into free fatty acid. It breaks down